in this video, as well as in the coming up 3 or 4 videos, I don't know, 3 or 4 videos or 2 or 3 videos, I don't know how much videos it will take to complete MVVM. We'll discuss about MVVM, why MVVM, and how to implement MVVM in WPF and Silverlight projects. Now, MVVM is nothing but it's an architecture pattern. It's a favorite architecture pattern, or else a preferred architecture pattern in WPF and Silverlight projects. MVVM stands for Model View View Model. In MVVM, we divide the project into 3 sections. The first one is a view, then we have the view model, and then we have the model. Now, in order to understand any software architecture, right, we need to understand its evolution. Remember, all the software architecture what you see today or what you will be seeing in the coming up times, it has an evolution history. For example, let's say 3-layer architecture. Before 3-layer architecture, we had something called as a 2-layer architecture. So in 2-layer architecture, we had first view, and then we had a data access layer. Then people felt no, we also need to have a separate layer for business logic. So from 2-layer, they created one more layer, and then that layer, when we create that layer, it became a 3-layer architecture. So, architectures, don't get created on the first day. It starts with something smaller, and then it evolves over a period of time. And the same holds true for MVVM. Now, if you ask any .NET developer, when I say .NET developer, it means developer who codes in ASP.NET, or probably who codes in Windows application, who codes in WPF application. If you tell him that what is the minimum base architecture in his mind, right, the first thing which flashes on is 3-layer architecture. So in this architecture, right, I'm sure that everybody is aware of it, but just for a quick revision, in this architecture, we divide the project into 3 logical pieces. One is UI, your user interface, the business layer, and data access layer. And each one of these layers handles and owns certain responsibilities. So the UI handles the presentation responsibility, the business layer handles validations, and data access layer handles SQL and transactions. And what is the advantage we get in 3-layer architecture? There are 2 big advantages. First one is contained changes. Contained changes means when you change in one layer, it does not replicate across other layers. Remember, a good software architecture is that architecture, where you make changes at one place, you don't have to go and change all across your project, right? So the first big advantage of 3-layer architecture is contained changes. And the second one is reusability, increased reusability. Now, because each layer is self-contained and individual, right, I can always go and take that layer, I can plug that layer outside, I can take it out from that 3-layer architecture and use it wherever I want to use it. For example, I can take the middle layer or my business logic layer and use it in WinForms, or I can take the same business logic layer and use it in a mobile application, right? So the second big advantage is reusability. MVVM is an evolution from 3-layer architecture. So what we'll do first is, we'll first try to understand a basic 3-layer architecture. We'll go through a basic 3-layer architecture code. We will look into what problems we have with this 3-layer architecture and why MVVM is needed. Okay. So as I have said previously, that every architecture evolves. Architecture do not happen in a day. So in the same way, MVVM has evolved from a 3-layer architecture. So what we'll do is we'll first understand 3-layer architecture. We'll go through the problems of 3-layer architecture, and then we'll see how MVVM solves that problem. Now, perception and reality are 2 different things, frankly. So for example, when you look at the 3-layer architecture, you feel that, yes, these 3 layers are divided or they are separated from each other, and all of these layers are having their own responsibilities, they are properly distributed. So if you change in one layer, the other layer will not get affected. But when you actually start writing the code of 3-layer architecture, and I'm sure that people who have already written the code of 3-layer architecture, you will see that some of the layers are performing extra work which they are not supposed to do. They are violating the S of solid. In case you are new to solid, I would suggest you to go to the architecture videos, where we have a nice video on solid principles. The S of solid says that what does the S stand for? S stands for SRP, single responsibility principle. So the single responsibility principle says that one class should take only one responsibility. If he's taking multiple responsibilities, then changes in other classes, can affect him. Okay. For example, now here we say, okay, the middle layer should only look at business logic. The UI should only look at look and feel. But in case, these layers, if they are taking some extra work, then what will happen is, if you change in one layer, there is a high possibility that you will change in other layer. And if that happens, that means, the benefit of 3-layer architecture is not there, right? Now the question is, what is this extra work, right? This extra work is nothing but, it is a code which sits and connects the layers. For example, the UI has to connect with the model, right? The model has to call the data access layer. So there is a code in between which connects both of these layers. We can term this code as glue code. Glue code means the code which actually connects both of these layers. Now primarily, there are two kinds of logic which will go into this glue code. The first kind of logic which goes between the user interface and the middle layer is mapping code. What does this mapping code do? This mapping code sends data from the user interface to the middle layer, or probably takes the data from the middle layer to the user interface. You can term this as mapping code, you can term this as binding logic, right? The second kind of glue code which goes between the UI and the middle layer is the transformation code. Now what exactly is this transformation code? Now many times what happens is, data formats of the middle layer and the user interfaces can be different. For example, you can see over here, I have a person object which has a gender property. Now the gender property has two values, M for male and F for female, right? But when this data has to be displayed on the user interface, it is a checkbox. So they don't understand M and F, they just understand true and false. So you can see that I have written a very simple transformation logic here saying, if the gender is M, then go and check this checkbox or else uncheck this checkbox, right? So this is one more type of logic or glue code logic which we need to write, which needs to be there between the user interface and the middle layer. So there are two kinds of glue code logic, mapping code and transformation code. But now the biggest question, who owns this binding logic and transformation logic? If you ask any developer, any .NET developer, that where will you put this logic, the answer is code behind. Now when I say code behind, a UI code behind, that means it becomes a part of the UI. Now the question here is this the responsibility of the user interface? What is the responsibility of the user interface? The responsibility of the user interface is look and feel, styles, positioning. The responsibility of the user interface is not to send and receive data, not to have such kind of transformation code, right? So let me show you a simple example and then I will go to the root problem and then we will see how MVVM solves this problem. Now one of the things which will come to your mind is, at least in this section, is that I talked about the glue code between user interface and middle layer. I did not talk about the glue code between middle layer and data access layer. Now remember, this MVVM pattern or MVVM, MVC, MVP, these are termed as GUI architecture pattern. They only solve the problem between the UI layer and the middle layer. They don't solve any kind of problem between middle layer and data access layer. For the glue code between middle layer and data access layer, for that we have something called as repository pattern. Okay, so must be repository pattern. We have one video which is there in the architecture video section, which talks about repository pattern. So MVVM solves the glue code problem between UI and middle layer. Okay, so in case you are interested in the glue code problem between middle layer and data access layer, then probably you need to look into repository pattern. Okay. So again, coming back to the point. So most of the developers put this code into the behind code of UI. That means it becomes a part of the UI layer. But the question here is, should UI be doing this work? Is it the responsibility of the user interface? Right? So let me show you a simple example and then we will go to the problem, what this behind code has, and then we will see how to solve it by using MVVM. So here is a simple example of a 3-layer architecture. And what I've done is I have actually excluded the third layer, that is data access layer, because as I've already said in the previous part of the videos, that MVVM pattern specifically deals with the glue code issue between the middle layer and the UI. So you can see over here, I have two projects here. One is the customer model class or the customer model project. So this is actually my middle layer, and then I have a UI here which I've termed it as without MVVM. Okay, and this UI actually consumes this customer model project. Okay, now the customer model project has a simple customer class here, and it has three properties. You can see customer name, amount, and a married property. Okay, and this married property is a string. So basically here, if it's a male, you have to say M. If it is a female, you have to say F. Okay, and then in the UI, when you create the object of this customer and when you display it, right? So if you look at the UI here very quickly, I'll just do a Control F5. This is my UI here. So you can see over here, whatever is the customer name is displayed as it is. Whatever is the sales amount, that is displayed as it is. But you can see here, first is I have an extra property here called as buying habits. This buying habits signify that depending on the sales amount, how aggressive the buyer is. For example, you can see if the buying value is above 2000, then the color should be red. If the buying goes above 3000, then the color should be green. So there is a color coding here, and this color coding depends on this buying value, right? And then there is a married property here, but you can see this married property is a checkbox, a true and a false. While here in my middle layer, the married property is a string. So you can see I have created a three-layer architecture. I have excluded the data access layer at this moment, and I'm concentrating mainly on the glue code between the middle layer and the UI. So customer name displayed as it is, sales amount displayed as it is. There is an extra property called as buying habits here, which is displayed on the UI, and this actually depends on the sales amount. And then finally I have a married property here, which is a string, but when it gets displayed on the UI, it is a checkbox. Now in the previous section of the video, I have said that glue code has two types of code, right? There are two kinds of glue code. One is the binding code, which just does the connection, and the other one is transformation code. So if you go here property wise, right? So you can see here this customer name property with this text box, whatever it is here, txt customer name, let's assume here we have only binding code. There is no transformation logic as such, so whatever is the value here, I have to just display in the text box, right? So customer name has binding code. Sales amount, again there is only binding code. So whatever is the amount, I have to just display it in the text box here. So only binding code. Now this buying habits, you can see it is a transformation code. In other words, whatever is the amount, I need to display it as a color over here. So again, this amount property with the buying habits is a transformation logic. Okay, look at this married property with this checkbox here. Now the married here is a string, and here I have to display it as a true and false checkbox. So again here there is a transformation logic. So customer name and sales amount only binding code, while buying habits and married, it is binding code plus transformation logic. And as I've said previously, if you ask any developer, where you should write this binding code and transformation logic, they write it in the behind code. So for example, in this project also, if you go to the XAML.cs, so for example, you can see this is my UI here, right? And if I go to the XAML.cs, you can see all my code over here. So you can see that what I've done here is, as soon as the project starts, right, or as soon as the UI starts, I've created the customer object. I have filled it with some data here, hard-coded data, and you can see that I have created a display UI function here. And in this display UI function, you can see that I have put all my binding and transformation logic code. So for example, I'll just make the fonts bigger here. So you can see this is binding code, right? This is again only binding code, right? This one here is a transformation code. Here depending on the amount, we have a buying habits logic, right? So you can see here it says that okay, the amount is greater than 2000, then basically set the color to blue, or else set the color to red, right? So here I have, how do you say, transformation logic, you can say conversion logic, whatever you say, conversion code plus binding code, right? Again you can see over here this is a conversion plus binding code. So in other words, this glue code which connects the UI and the middle layer normally finds its path in the behind code. Now there are a couple of problems, the time these kind of codes go into behind code. Okay, now remember, currently this project is so simple, so that's why I have hardly must be 10-15 lines of code. But I'm sure that if you have worked with bigger projects, the behind code becomes messy. It becomes unreadable. So many events, so many clicks, in every of the clicks there is something happening, right? So the next question is, if this code goes into the behind code, what is the problem, right? What is the issue with it? The first problem is reusability, or I'll say the biggest problem is reusability. Think about, that in the same application, I have a screen like this. Now that screen was a display screen. Okay. Let's say we have a data entry screen like this. Now over here, the person comes and he types his name, he types the amount, and depending on what amount he has typed, I want to go and, show the color red or blue. So in other words, that buying habits logic I want to execute here. Now how do I do it? Because that code is lying in that behind code of a different XAML.cs, and this is a different XAML over here. How do I call that method or the function which is over there, right? Or let me take this thing one step ahead. What if I want to use that glue code logic across different UI technologies? For example, that I have a WinForm, let's say. I have a mobile UI. I have a MVC UI. So what if that color logic and that male and female transforming it to true and false, I want to go and use it in different UI technology. Now we are not even talking about WPF, cross-platform, right? How do I do that? Okay. So the first problem here is reusability. And remember, and you will also agree to this, that when you look at the code, the number of lines of code, right, in your UI, in your middle layer, in your data access layer, the maximum code goes in the behind code. It is the maximum code and it is the most cryptic code, believe me, right? So if that code cannot be reused, then it's a problem, right? Okay. So the first problem is that how do I reuse that behind code? Now again, I would like to talk more about this behind code. This behind code currently is attached very specifically with the UI technology. For example, this display UI function is currently residing in this class main window without MVVM, and this class inherits from system.windows.windows. So this code is very much tied up with the Windows UI. So if let's say ASP.NET UI wants to use it, it is very difficult, right? Because that would look very absurd that a ASP.NET web application is trying to use a Windows form behind code. So again, the biggest hurdle for reusability is that the complete code is tied up with the UI technology. So how do we solve this reusability problem? How do we make the code behind reusable? Now this is not a rocket science. I'm sure that most of the developers already know the answer. Move the behind code to a class library, right? So the way to solve the problem is, if you want to make something reusable, we have to create a DLL. In other words, we have to create a class, right? So the solution is that basically whatever is our XAML, we'll create a view out of it. Whatever is the behind code, that is the XAML.cs, we'll create a view model class out of this. Why the name is view model? Because it has the logic which binds the view and the model. So all the glue code will move it into a class library. And once the code has moved it to a class library, we can reuse it anywhere. We have to just add a reference, right? Add the DLL reference and start using it, right? So let's go ahead and try to implement this solution. So let us go ahead and add a C# class library called as customer view model. Okay. So let me right click the solution here and let me go ahead and add new project, and let me select this class library here. So this is going to be a class library project, right? And let's name this library as customer view model. So there it is. Now we have three projects here. The first one is the without MVVM, which is the UI, our view. Then we have the view model class library, that is customer view model, and then finally we have the model. So in other words, what will happen is the first hit will come to the view will invoke the view model, and then the view model will invoke the model. right? And that's what MVVM pattern is all about. In MVVM, we divide the project into 3 sections: view, so this is the view model, so this class library is a view model, and the model, which is our actual class library, right? And the customer view model will refer the customer model. So I will add a reference to the customer model. So there it is. And the view will have no reference to the model directly. So we need to first go and remove this reference from here, what we have. So I'm going to go and remove the customer model reference, but the view will refer the customer view model, right? So I will add a reference of the customer view model library. So you can see that I made some major changes to the references here. So now in the customer view model library, let us go ahead and create a class here called as cust view model, right? And so this customer view model class, or this customer view model library, will be using the customer model internally, right? So all the calls from the view will come to this customer view model, and the customer view model will send those calls to the model. So you can see that I'm creating the model object inside the cust view model class. So you can see that I made a private object here, obj equal to new customer. So all the hits, will come from the view here, to the cust view model, and the cust view model will then send all those messages to the customer class. Now the next thing is we also need to go and create public properties, and those public properties will internally go and call the model properties. So let's first go ahead and create at least 2 properties, one for the customer name and one for the amount, right? So if you remember, on the customer screen we had customer name, we had amount, then we had the color, and then we had the gender checkbox, right? The gender option button, I'll say rather. So so let me first go ahead and add 2 properties here. You can see that I have added 2 properties. One is the customer name and the other one is the amount. Now the first noticeable thing about these properties are that I have given them UI naming convention. So you can see that over here I have given the name as txt customer name. You can see that I have given the name here as txt amount. So it says that this will bind to a text box called as txt customer name. This will bind to a text box called as txt amount. So you can see how I am keeping the naming convention in such a way that this class represents my user interface. Okay. And also you can see that this class is also taking up a lot of other things, like for example, the amount is a double. So all the conversion also the view model class is doing. So it is not only taking up the glue code, but it is also taking up all those responsibilities from the UI, of casting or typecasting or whatever it is, right? So I have already added the 2 properties, customer name and amount. Now the next property what we have in this UI here is the buying habits. Now remember, this buying habits is nothing but it's a color, right? It actually represents a color, depending on the amount field we have, right? So I'm going to go and add one more property here, and I will name this property as LBL amount color. And you can see that this LBL amount color, depending on what the amount is, right, what the value of the amount is, it is returning either blue color, it is returning either red color, or it is returning either yellow color. Now one of the noticeable thing about this property what I have created here is I have created the property type as string. I did not create a property type like a solid color brush object, or some UI specific element I did not use, or the UI specific class I did not use here. I used the least denominator data type, string. So now it's either a HTML UI, it is either a WPF UI, it is either a WinForm or ASP.NET, whatever it is, right? So they all understand blue, red and yellow color, right? So I will not get into their UI specific elements or UI specific classes, how to transform this blue color into a blue color brush object. That I will not get into. I will leave that to the UI. So you can see one of the important things about view model is that whatever data you are exposing from the view model, it should be of the least denominator data type. Do not try to use UI specific data type. UI technology specific data type means, in other words, do not expose from here solid color brush object of WPF. If you do that, then you are again defeating the whole purpose of view model, right? Now the next property what we have in our UI is the married property, right? Now in the model, this married is a string. So basically, if you find the word married, that means the person is married, or else it is unmarried. But on the UI, it is a checkbox. In other words, the married should be now converted to a true value, and whatever is not married or it does not have the text married, it should be unchecked or it should be false, right? So for that, let's again go ahead and expose one more property from this view model class here. So I'm going to go and create one more property here, and let's name this property as is married. So you can see now this property is returning a Boolean data type, true and false. So it says that, okay, if I find this word married, then I will return true, or else I will return false. So you can see now how I have created this cust view model class, which actually reflects my UI. Okay, look at the naming convention, how they are reflecting my UI properties: txt customer name, txt amount, lbl amount color, is married, right? So now that I am done with my cust view model, now the next thing is I need to take this cust view model and apply it on my UI, right? Now, right from the start of this video, I have been cursing the behind code so much, right? So it is time now to get rid of this complete behind code. So now that we have the view model class here, and this view model class has all the behind code inside it, so we don't need any kind of behind code now in the XAML.cs, right? So what I'm going to do is I'm going to go and delete all the code behind at this moment. So let me go and remove all this code behind over here, and the only code behind what we have is the WPF initialize component method and the constructor, right? Because without this, the WPF UI will not fire, right? So we have got rid of the behind code. Now the next thing is we need to go and consume this view model class inside the XAML over here, right? And in order to consume this view model class inside the XAML over here, we need to use bindings. Now in case you are new to bindings, what my suggestion is to go and see the WPF bindings videos, which we have in the WPF questions and answers video series, where we have explained what is binding and how to use bindings. So in this video, I'm not going to explain about what is bindings. I'm going to go straight forward and use bindings to consume that customer view model class inside. So the first step is to go ahead and give the XML namespace here. So I'm going to say here XML NS, and I'll say this is cust NS, and we need to also point towards the namespace. So I'll say customer view model here, right? And to create the object, we need to go and use the resources tag. So I'll say here window.resources. So in case you are new to resources, in case you are new to bindings, again my suggestion is to go and see the video of bindings, of WPF bindings, so that you'll understand what I'm doing here. So I'll say here cust NS. I'll say I want to go and create an object of this cust view model class with the name, let's say cust obj, okay? And I would like to set the amount as, let's say 1000, right? I would like to set name as, let's say Shiv, right? And I would like to set the married as true, right? So I've just put some hard-coded data at this moment here, right? Now the next thing is we also need to go and bind all of these properties with the labels here. So you can see here that I have this label text here, and the other one also I have one more label here for each one of these text, which actually will show the actual data. So let me now go here, let me go to this label here, let me go to the content, and so I'm first starting to bind the customer name, okay? So I'll say create data binding, and I'll say that, okay, it's a static resource, so I will first go and bind the name here, right? The second property, this label I will bind it with the amount, right? So this is LBL amount, so I'll bind it with the amount property, txt amount property. Remember, in our customer view model class we had txt amount. So again over here I'll say okay, bind it with txt amount. Buying habits is a this property we will bind it with the color, right? So we would like to set the background color. So this background color will be binded with LBL amount color, right? Okay. In the same way, finally the married checkbox, right? Again over here we'll bind the is checked property with is married property, right? So go and bind this is married, and there it is. So you can see now, because this value is 1000, is showing a yellow color here, right? So you can see now, how smartly we have moved that behind code into a customer view model class. Okay, and now that customer view model class, we can add the reference of this customer view model class into any other project like ASP.NET, or must be MVC, or must be Windows form, and we can reuse the behind code, right? And also you saw that how I got rid of the complete behind code from here. You can see now absolutely I don't have any behind code. All the behind code is currently into this customer view model class, right? So this was the most simplest example of MVVM. So in MVVM what we do is we divide our project into 3 sections. Okay, the first one is the view. So this without MVVM is the view. The second one is a customer view model class, which actually has all the glue code, your behind code. It has the transformation logic, it has the binding logic, and the last one is our customer model, right? So MVVM helps us to create reusable behind code, you can think about. Okay, so your behind code which was not reusable, because it is now moved to a separate class library, it is reusable. And because of bindings, we don't need to write any kind of binding code. Because of the beauty of WPF bindings, you can see that I just went ahead, I selected every label and I just started binding it. So because of the beauty of WPF bindings, it adds more color to the MVVM architecture, and thus leading to absolutely no behind code. Now in other UI technologies like ASP.NET or must be Windows form, right, there is nothing like bindings over there, right? So definitely you will have to write a code at least for binding the values of the UI and the text box, right? So I hope that you have enjoyed this video. So this video was the most simplest form of MVVM. So we first started with a 3-layer architecture. We talked about the glue code problem. Then we smartly moved that glue code into a class library, and then we used WPF binding and we arrived to the 0 behind code, right? Now in the next video of WPF MVVM, we'll talk about commands. Now this UI over here, it is good. It has labels, it has checkboxes, but normally user interface will also have text boxes. They will have buttons, right? So if I want to send any kind of actions like button click, right click, left click, right, how does MVVM work? Okay, so in the next video what we'll do is we'll raise the MVVM bar bit higher, and we'll talk about MVVM with WPF commands. Thank you so much.